So in this chapter today, we'll be talking about the concept of a digital twin, and specifically how we can emulate digital twin by developing something called as a GitHub GPT, right? So let's get started. So first of all, what is a digital twin? So we asked our friend ChatGPT that, okay, what is the digital twin? And this is what it has to reply. A digital twin is a virtual replica. Virtual because it's not real, it's a virtual thing. Replica of the real system, process, or organization. So how does it help? It helps in the such scenarios. For example, let's say you have an organization in place, and then a couple of employees leave your organization. No? So how do you keep a track of all the work which the particular associates would have done? In that case, you might need something called as a digital twin of that particular associate, such that you would have an intelligent record of whatever the person has done. So it's not just a static repository of whatever the person has done in the past, but it would be slightly more intelligent in the sense that you would enable AI also into that. Right? So that is the concept of a digital twin. It helps you keep, as it's saying, it helps you retain the knowledge and also documentation, and that would be automated, leveraging the LLMs. So that is one digital twin, and it would make the life of a project manager really easy. For example, let's say you're a project manager, and then a couple of your employees or your associates are out on vacation, and if you want to keep a track of what your work has been done in the past, right? If you want to find out what they have done in GitHub or SharePoint, etc., then you can all integrate these elements, that is GitHub, SharePoint, all the different code bases, Jira, etc., and then try to find out what the person has done, so that even in their absence you will get to know. And this is where a digital twin comes in extremely handy, right? So that is that. Now let's talk about the GPT of GitHub and what was the rationale for doing that. So as I was saying, when you develop a digital twin, you will have different aspects to it. So the associate might have worked on GitHub, the associate might have worked on a couple of SharePoint folders, etc. But we are just emulating one part of it. So let's say that we have developed a GPT which is trained just on the GitHub repository of that associate. In future, you might also want to integrate it with the different aspects such as the SharePoint, maybe even Outlook, right? And the different aspects of the person works, so that you can get to know what the person has done in the past. Okay. But in this small episode, I just wanted to take you through that if you want to develop something like a digital twin of the GitHub, in which case you would want to see whatever the code the person has written, you can do something like this. So what is the logic of this? Right. So the first aspect of a GitHub GPT is that the GitHub repository of that particular associate will need to be crawled, right? And then what happens is embeddings of the contents are created. When I say embedding, it is nothing but the numerical representation, right? The vectorial representation of the text. So the LLMs don't understand, the machines don't understand language. What they understand is the embeddings, the numerical formats which is there hidden behind those texts, right? So that is what it is. Every text is converted into a numerical format and then it is stored. All right. Now, before I go to the third block, let me talk about a couple of things such as RAG, right? Which is nothing but a form in which you get to extract the relevant answers from a large text, right? So how is that done? So that is done using this process. So let's imagine that over here we are asking a question such as what is the LangChain, LangChain chain, right? So that is a prompt. So what happens is at the backend, this entire query, what is a LangChain chain, gets embedded in the sense that it is converted into a numerical format. Now it's getting converted into a numerical format, and then you have a vector store. Vector store is again nothing but a fancy term for a large database which has all the text in the numerical format, because as I said, the machines understand the numbers, not the text per se. So all those text, whatever is there, is stored in a numerical format. In our context, the code of the GitHub would be stored into the vector format, into the number format. Now, when we are asking question, that particular question is also converted into a number format, and then the similarity score is calculated. The similarity score could be different. It could be depending on the Euclidean distance. It could be depending on the cosine similarity score. So there are n aspects, but the thing is, we want to calculate the similarity score and find out that specific embedding which has the highest similarity score to your question, right? So it essentially means finding that part in the large document, right? Finding that specific part which is relevant to your question. So for example, what is a LangChain chain in this document? Let's say you have 1,000 pages and only one paragraph relates to a LangChain chain. So using this, you can extract that particular paragraph which is relevant to you, which answers the question, what is a LangChain chain? And then it is given back to the LLM. Sorry, then it is passed back to this context, right? And then this, the query plus the context, right, is passed to the LLM, which then produces the answers using the query and the context. So the similar thing happens over there. Now coming back to our scenario, we have already crawled the content of GitHub. These embeddings are created and stored in a vector store. Now, when the user asks a question, so for example, let's say, what is the content of this specific repository? It will be converted into an embedding, then it will be passed to a vector score. The similarity score will be found out. That specific part of the entire repository, right, which is relevant for the question, will then be passed on to this block, right? And then the query and the particular part of the repository which is relevant to the question will be passed to the LLM, which will be then be answering the question, right? So this is what it is happening. User asks a question and the context is created, and then RAG is deployed. RAG is nothing but the entire process which I just talked about in this diagram is deployed to get the answers for the question in the understandable form, and then it is passed to the LLM, which then produces answers the user has asked, right? So that is what is going to happen. Now let's get to our code, right? So this is a GitHub LLM chatbot. So what I've done is I've crawled the GitHub content of the person. I'll be crawling that. So, and I'll be doing it on the fly. So it might take some time. So this is what the local host is running on my local system. GitHub username to crawl. So I've given my profile and then I'll click on this because it is going to crawl the contents, right, recursively. When I say recursively, it will go to the first of all the main repository, then it will go on finding all the files within files, etc. So it might take some time. All right, so now you see it is fetching this, and then after some time it will be embedding that. So I'll put the video on the pause, and once it finishes, then I'll just resume it. So we are back. Now the GitHub username to crawl, this was mine. So it crawled that, and then I found the user. It also found out that there are 23 public repos into that, and it indexed 8 files, including the README and code. And these are the few repositories. The maximum limit repository I had given was 5, right? So 5 to crawl because this is just a demo purpose, but in real time scenario, you can keep it as many as you would want. And as I said, it is going to do it recursively. So it would have found out all the contents of these specific repos, right? Now let's start. Now the fun starts. So we'll ask, okay, how many repos does the user have? Okay, so it gives the right answer. The user has 23 published repositories. Okay, now let's ask at random. Let's ask, okay, what is there in chat PDF2 repository? So let's ask, what are contents of the PDF2 repository? And this LLM, in fact, is a Groq based one. So I've used the free version of that. In one of my videos, I can tell you how I use that. But essentially, I'm paying nothing. I'm using Groq as the inference engine, and within that, there are a couple of available LLMs which I have used, and it's absolutely free. That's the best use for us. So you see, I asked what are the contents of chat PDF repo, and then it told me, okay, these are the contents, and please just don't ignore this. This is going just for our purpose. It tells you what is the similarity score of all these files as compared to whatever was asked. Okay. Now it tells, okay, once it found out this, then it also gives some commentary on what is the content of the chat PDF2 repository. So it says that appears to be Streamlit, which is right, for chat-based PDF analysis, 100% right. And then it tells you that what it does is using LangChain, the user can upload a PDF file. I mean, it is mind-boggling. Please do remember, I didn't mention any of these while I was writing this. There's nothing like that in the README file, but it was quite intelligent enough to tell me that, okay, this is what it is. And then it is also giving us a code snippet from this. So let's say we want the entire content, so I can ask me, I can ask is the entire content of this. And then it will give us the entire content of the code of this. Again, it uses the RAG phenomenon which I just explained a few minutes back. Fantabulous. You see, it gives the entire content is the full code of mine of chat PDF2 main finance.2.py. So just imagine how really amazing it is. Using this, you can keep a track of everyone's work, and I think it would be a huge asset for the project managers who would want to leverage AI and make their life simple. And just as I said, you can develop such type of GPTs on top of SharePoint, on top of all the other aspects where the user works, right? And then make a GPT on top of it so that you will have a digital twin of the user, and you need not worry about the person going on leave, etc. And